এটাকে একটু গুছিয়ে একটা ফর্মুলা বানায় করাই তোমাদের, so I'll give you the formula right now, okay? But you get the main essence of it, what this is. So number one, internal resistance is a resistance that's inside a battery due to all its components and parts and everything. It is something that's inevitable, right? And because of it, the voltage the EMF that's provided by the battery, right, is lost inside the battery, and then it's given to you. So eventually you'll always get less than the EMF. You get my point? So can you give me a consequence of this loss on the battery? Battery kichu hoy ei consequence je bhitore je loss hoye jacche voltage ta, does something happen to the battery because of this loss? Yeah, basically heats up. Okay, so battery গরম হয়ে যায়, use করলে কেন গরম হয়? Internal loss. And the batteries that heat up a lot are the ones that have a lot of internal resistance. Because you know that internal resistance 0.2 volts, but the heat হিসাবে dissipate হবে eventually, right? So that's the loss that takes place. So very high quality batteries, right, don't really heat up. And heat up করলে কিন্তু battery performance খারাপ হয়ে যায়. Because once you heat up the battery, as she mentioned, conduction খারাপ হয়ে যায় and it starts to falter. Phone battery গরম হয়ে গেলে যেমন it's a problem. And sometimes some phones shut down themselves, right? So yeah, the point I'm trying to say here is that that loss actually goes inside the battery and the battery heats up, okay? Right, so that's internal resistance. So এখন আমরা একটু formula যেটা derive করতে বলে ওরা ওটা একটু দেখি, probably the most basic derivation in your syllabus. So একটু দেখো কি হচ্ছে এখানে basically terms গুলো important. They'll give you some names here, ওই নামগুলো ওরা question use করে, তো তার জন্য করাচ্ছি. So you have a circuit here, and there is a current in this circuit, which is I. ওরা চায় যে তোমরা Kirchhoff law use করে একটা equation derive করো, okay? So let's do that. এটা resistance হচ্ছে R. Can you tell me, show a screen, if I take a loop like this, okay, let's take the loop like this. If I take a loop like this, I'll have to use sum of EMF is equal to sum of PD, potential differences, right? The sum of EMF in this loop is how much? Just E, আর তো কিছু নাই, পুরো লুপের মধ্যে খালি একটা ব্যাটারি না, so E, correct, is equal to the sum of potential differences. কি হবে? Very good. I smaller plus I bigger, because there are two resistances out there, right? So I smaller plus I bigger. Now এটাই কিন্তু ডেরিভেশনটা, বাট ওরা কি করে প্রত্যেকটার নাম দেয় আলাদা করে। I'll explain কি করে ওরা এটাকে হচ্ছে রিফ্রেজ করে by converting I capital R into something called VT, V with the subscript T. Eta is called terminal voltage. What's terminal voltage? Let me explain. Terminal voltage is the voltage that a person will receive at the what of the battery? Terminals of the battery. So আমার battery terminals এ যখন আমি হচ্ছে আমার ভোল্টেজটা পাবো, right, ওইটা কি আমাকে EMF দিবে নাকি EMF থেকে loss minus করে দিবে? Right, so আমার কিন্তু loss ভিতরে হয়ে যাচ্ছে, বাইরে হয় না, so everything happens inside. বাকি যেটা টার্মিনাল থেকে বের হয়, that's what we actually get, right? ওটা কেমনে বের করতে পারবো? EMF minus loss, right? So the name they give to that particular voltage is called V terminal, VT, right? এটা একটা, and this IR যেটা, this one, what can you call this? I already named it. Internal loss. That's the loss that takes place, right? So eventually, or formula derive kore VT, and you'll find this very often in your MCQ paper, minus IR. So that's the formula that you need to be learning and using. But I personally feel like the basic circuit, it's the same. I'll check it out. Right. So copy. Then we'll do some questions. There are a couple of problems. This is called terminal DD. This is internal loss. Internal loss. Because there is a small R is giving you internal resistance. Just a second. No. And your syllabus with focus on waves. So your electricity and particle physics questions will be replaced with waves questions. So it'll be a full mark. And date যেমন হচ্ছে Google Classroom যেটা দেওয়া, that's not the appropriate date. I mean, অন্য ব্যাচেটা দিয়ে দিয়েছিলাম তোমাদের তো ক্লাসেস হয় সানডেজ এন্ড টিউসডেজ, সো 4th and 6th হবে, not 5th and 7th. Shouldn't be a problem. We used to keep it closed previous years, but after 12, it's like fully open and everything. If there is an issue, right, you can always come on some other day and give them off. Are you guys done? Yeah, the first exam, যেটা হচ্ছে 4th হবে, that's going to be paper 1, and তারপরটা হচ্ছে paper 2. Will your schools be closed? তাহলে ভালো, তাহলে সকালবেলা আমি অনলাইন ক্লাস নেবো, যে স্কুল ক্লোজ থাকে। পেজ 95 এর পাশে এটা লিখো। আচ্ছা, তাড়াতাড়ি করে আজকে শেষ করতে হবে এটা, we have few more things pending. I'll upload this, so তোমাদের যদি বুঝার কিছু থাকে আমাকে জিজ্ঞেস করতে পারো, or else I'll get into the other part on this. আচ্ছা, ঠিক আছে, okay. Mock is entire syllabus. Entire syllabus মানে electricity দিতে পারবো না এখন, because I haven't completed it yet. So wait পর্যন্ত. So if you're doing paper 1 for practice, question 30 পর্যন্ত পারবা. 30 is still waste, or 30 থেকে 40 is like electricity and particle physics. Done? Okay, let's see a question. So try this. Make it fast. এখানে একটা গ্রাফ করতে হবে, আজকে এটা wrap up করতেই হবে. The terminal PD across a battery is 8.6 volts. The EMF is 9 volts. And a load resistance, or a what to use for load resistance, when the external resistance load that is 100 ohm. Find the internal resistance. So this is the only way you can find internal resistance. Actually, just one thing before you start. Can you measure internal resistance, or can you calculate internal resistance? Yeah, because measure করার কিছু নাই তো, what are you gonna measure it across, right? So to calculate করতে, this is how you do it. 4.65 ohms. 4.65. Yeah, I think so. Molam, there's a graph that I need to do, so hurry up. $4.65, yes. All right, so what's going on here? You have a battery, and battery পাশে there is an internal resistance there, যেটা value আমরা জানি না, R. The EMF of the battery is 9 volts, and external resistance provided is 100 ohms. Right, so this is 100 ohms, and that's about it. Also, the terminal PD is 8.6 volts. Right, so find internal resistance for this battery. This is the outer border, right? Could be easy. First, তোমাকে কি বের করতে হবে? Current ছাড়া কিছু করা যাবে না. So you're going to use this part here to find your current. V equals to IR. Voltage is 8.6. Current is unknown. Resistance is 100. So your current is going to be how much? 0.086 ampere. then you can use the formula that I gave you, or you can just design it yourself from a paper. Na formula that you use kori amra. Terminal PD equals to what? EMF minus I small r, right? So terminal PD koto ekhane 8.6, EMF koto 9. What's my current here? 0.086 into R. And once you do the math here, jeta ashe otai answer koto 4.65 ohms. That's how you find and calculate internal resistance. Okay, our because these are the only things you can actually measure in a circuit. Rest of them are calculations. Okay, let's move on. Oh, without the formula, which is Kirchhoff's second law. Oh, so then you'll end up with the formula again. Okay. Right. So let's see what can we do with this equation. Screen some students claim this is complicated, so I get the heads up data it to attention here. So basically what we're going to do is plot a graph here for voltage versus current for your circuit here. Now I have a question for you. Answer if I keep changing my resistance, external resistance, internal loss ki same thake na change hote thake? Our body, if I keep changing my external resistance, right, the internal loss, does it keep same or does it change? Yes, আজকে তো দেখলাম 100, 400, 4.65 সব same ছিল, but loss change হচ্ছিল. Internal loss and internal resistance কিন্তু আলাদা. Internal resistance is the value of the resistance. Internal loss is what? The potential difference inside. ওটা change হতে থাকে. And ওটা can change হতে থাকে. What's the formula for the internal loss? I small r. Small r fixed, but capital I data current already fixed. No, different circuit, different value, and that's where the loss keeps changing. Okay, so somebody wanted to figure this out. Investigate like what's the relationship here, right? So we had to come up with a graph, and graph. This is your R, like external resistance. This is EMF, and the circuit has a current here, which is I. And we know that the formula that you get here for the voltage across this, our voltmeter connected across the resistor, right? Can you tell me what do we call this voltage? The voltage across this resistor? A potential difference. Terminal PD. Terminal PD key. Terminal PD is a voltage that you get outside your battery, right? So just say resistor, there's no one else here, right? So this is your VT. Now, our formula the one that we derived, VT is equal to what? EMF minus IR. Does this format of equation ring any bell? এভাবে কোনো কিছু কি জানো তোমরা math that has like a format that's similar to this? Yeah, the straight line equation, y equals to mx plus c, right? I'll explain how. So if you try to make a graph out of this, right? আমার যদি হচ্ছে x axis থেকে আমি হচ্ছে voltage দেই, current দেই, and y axis থেকে যদি voltage দেই, how can you rearrange this equation to be a straight line? Super easy. So what you're going to do here is compare this with which equation? Y equals to mx plus c. Do you agree? Where y would be my what? Terminal PD. C, the intercept should be what? EMF. Our x-axis is key? Current. So what should the gradient of the graph give you? Internal resistance, right? So I should actually get a what line when I vary these quantities, a straight line, right? And that's indeed what happens. So if you ever plot this graph, right, in your practicals, you'll find that practicals is a comma shaded though. But if you plot a graph here, you'll find that it's supposed to be a straight line. Okay. Now, do you think the graph will be a positive gradient or negative gradient? Yeah. So you can come minus R. Now, can you tell me if I extrapolate my graph? Do you know what I mean by that? I extend the graph, right? It'll go and meet the y-axis at a particular location. What is it? A y-axis is value key. Yes, very good. So that's going to be my EMF here. And the gradient of this graph, as already mentioned, internal resistance, right? So negative internal resistance. So there's a small issue here. Or how do you find internal resistance? And the students will say gradient of the graph, right? That's actually incorrect. Ki hobe? Negative gradient. When R equals to what is the question? R equals to what? Minus gradient, right? So therefore, internal resistance is equal to minus gradient of this graph. Are you with me so far? Acha, okay. So this is the graph for your circuit here. এখন আমার একটা question, okay? How do I find the EMF of a battery? Measure between the two terminals, but wouldn't that mean terminal PD?
So we have to first measure the terminal PD, then we have to calculate the internal loss, and then.
But for internal loss, you need EMF. Huh? No, I mean that's true actually, but they are usually not consistent. Plotting a graph, no, practically. So battery, tell me what's its EMF. What do you do? Voltmeter there. Voltmeter there ki korbo? Imaginary voltmeter. So yeah, I hold my voltmeter here, tarpor. And wouldn't that be terminal PD? No graphs. So
is what EMF is.
The loss of an ভিতরে
We calculate.
No, calculate can be করবো. So we're now lost here because the whole thing was based on the assumption we know EMF, right? And the EMF জানি না. So EMF কেমনে বের করা যায়? না, তো বললাম তো ওরা 6 বলছে না, এটা 6 না, এটা ফার্স্ট ডে থেকে 6 ছিল না, because of weather conditions, whatever, it started off like 5. No. Acha, Ampoli, you guys were very close, but your confidence didn't really show up. I'll tell you ki korte hai. You take a voltmeter and just connect it at the terminals, okay? However, here's the thing though. It has to be connected to an open circuit, because an open circuit has what current passing through? So what would my loss be? 0. Okay, so whenever you want to find the EMF of a battery, you connect it to your circuit, but it should be a what circuit that you connect it to? Open circuit. Because open circuit to current flow korbe na. Ar current flow na korle hocche IR te ki hobe? 0. So VT equals to EMF, right? So it's a very important thing, and you can notice this here because some of you probably could have read it from the graph. It is EMF na? EMF for current value koto? 0. So you just have to make your circuit current 0 to find EMF. And the easiest way is what? Open the circuit. Okay. So the voltmeter creates a circuit with this battery, right? But voltmeter current pass loss, so directly show voltage show. Okay. So the way to find the EMF of a battery, right, practically, is something that you probably will have done intuitively. The battery, this is not your find EMF. You'll just connect them on the terminals, right? Why is it not showing you internal loss? Because by doing so, you're preventing what from flowing through your circuit current, and that's what the loss is there anymore, right? Okay, so last thing before we move on, draw the graph for this circuit. So I mean, you graph same graph, draw and everything. But I'm going to make a small change in my circuit, okay? What we're going to do right now is use two batteries in series. So if you place batteries in series like this, right? Graph here, draw is one of the most popular and used from the chapter. Okay. It's not the only thing. I really see anything else showing up that often. So yeah, how would the graph look like? And by the way, the graph has to be based on this graph. Actually relate per draw. Okay. So just draw a random graph. Show it with references. How does it compare to this one? I will admit it's a little challenging. Some students struggle with it. Same thing, but the batteries are the same what to each other. Parallel, okay? Parallel batteries is something we haven't done because syllabus night, but or I can teach for it. So I'll also teach you a bit about parallel batteries when we do this. But the point, series parallel পরে দেখতেছি আমরা। So how would the graph look like when your internal resistances are, your batteries are in series, which is nothing abnormal, by the way. That's what batteries are in most appliances. They're placed in series, right? So how would the graph compare?
So I have a question. So adapter for the base to find
Adapter charge in adapter with your resistor can থাকে resistor na fuse
Sure, I saw it.
এখন এটি কি টাইপের adapter, like do you mean like ওগুলোর ভিতরে multiple reasons ওটার ভিতরে একটা ট্রান্সফর্মার থাকে first of all ওই ট্রান্সফর্মারটার কারেন্ট রেস্ট্রিক্ট করার জন্য একটা রেজিস্টার ইউজ করা হয় রিজন বিং দ্যাট তোমার যখন কারেন্ট হচ্ছে মেইন সাপ্লাই থেকে আসে ওটা কিন্তু কারেন্ট স্টেপ আপ করে আর ভোল্টেজকে স্টেপ ডাউন করে দেয় ওই ওয়্যার যেগুলাতে কারেন্টটা যায় রাইট ক্যান হিট আপ আ লট সো হোয়াট দে ডু ইজ দে প্লেস এ রেজিস্টার টু রেস্ট্রিক্ট ইট ওকে সো ওইটাই মেইন রিজন হয় বাট ফিউজ থাকে you can overcharge. It has a capacity, and as it reaches the capacity, it stops. It basically reaches equilibrium. You can't go beyond it. So overcharge will korta, like 3 days extra charge niye nita. See what happens. It'll go to 100 and it'll stop.
There's another myth when we used to buy appliances, minimum 8 hours charge. The logic.
But actually true.
What about now?
No, now as well. I'll tell you why. Batteries যখন plant থেকে বের হয়, like factory থেকে, they put the batteries in something called a low power mode. কারণ ব্যাটারিজ এর ভিতরে একটা গ্যাস জমে ব্যাটারি ফুলে উঠে, সো লো পাওয়ার মোডে রেখে দিতে হয়। সো তুমি যখন 8 hours চার্জ করবা and you reach the 100% mark, তখন ওই লো পাওয়ার মোডটা অফ হয়ে যায় and it goes into performance mode. So most of the time যেটা হয় অনেকে এনে চালায় প্যাক করে রাখে টেস্ট করার জন্য, লাগে না, but if you get it fresh from factories, right, it's always low power mode. কারণ ওই লো পাওয়ার মোড ছাড়া নালে all the batteries are stored in a shelf, right? ওইখানে over time কিন্তু they will start to release the gas, they'll heat up, so ওটাকে low power রেখে দেয়। Nothing wrong.
Nothing wrong.
No, what's wrong with it? Yeah, it's not wise to put your phone on charge and keep it next to your head when you're sleeping, because there are cases of batteries catching fire, but using a phone on charge is not a problem. If you go to phone stores, right, or display in forever charger forever, like day 1 to day 0, like whenever it's sold, right, or thrown away, it's always charged. They never catch fire, they never explode. আগেরটার সাথে কম্পেয়ার করতে হবে, মানে you have to draw both the graphs together. Yes. আচ্ছা করে দেই একটু এদিকে স্ক্রিনে, I think we are out of time. সবাই একটু স্ক্রিনে দেখো, how does graph look like? So the graph here, and one of you got it right, so very good. The graph here is supposed to look something like this. So if this is the original graph, right, the one that I have drawn before, the new one has 2 batteries, right? So what should the EMF be? 2E, right? So most students for MCQ the option থাকে, they'll go for the double D, right? But then there are 2 resistors in series to each other, right? So R and R. So what's the total internal resistance of this circuit? 2R. And since the gradient is internal resistance gradient কি flatter হবে না steeper হবে? Exactly. এরকম দেখতে হবে. So that's the graph for our new setup. So this is 2E and this is minus 2R. Parallel to next class because I can't rush through it. Our next class is on Thursday, right? Thursday we'll start potential divider as the next topic.
From the user that we can answer how did they
Just হ্যাঁ, তুমি একটা মাইক্রোওয়েভ টেলিস্কোপ ব্যবহার করো, তুমি আকাশে পয়েন্ট করো, দেখবো মাইক্রোওয়েভ টেলিস্কোপটা পুরো হোয়াইট হয়ে গেছে। কি দিয়ে হোয়াইট হয়ে গেছে? মাইক্রোওয়েভ দিয়ে। কারণ তুমি সব দিকে পয়েন্ট করো, দেখবো যেদিকে তাকাচ্ছ সব দিকে মাইক্রোওয়েভ। So that means it's just everywhere. So it's a direct radiation.
হ্যাঁ, লাইক there's একটা ম্যাপের মতো ক্রিয়েট করতে হচ্ছে যে এখানে রেড কালার, ওইটা কিভাবে ম্যাপ আউট করছে?
মানে কসমিক মাইক্রোওয়েভ দিয়ে ওটা হচ্ছে ভেরিয়েশন ইন ইন্টেন্সিটি, এন্ড ওটা কেন হয়? তোমার রেডিয়েশন ইজ কামিং ফ্রম এভরিওয়্যার, বাট ওটার সামনে তো ইউ হ্যাভ লাইক ডিফারেন্ট ম্যাসেস। ওই ম্যাস গুলো তোমার রেডিয়েশনকে কি করে? একটু ব্লক করে। তাছাড়া দেখবা যে একটু শ্যাডো দেখা যায়, বাট দেয়ার এভরিওয়্যার এন্ড ইটস জাস্ট মাইক্রোওয়েভ।
সো এটা ওরা বুঝলো কেমনে যে
রাইট, সো যেটা হচ্ছে যে মাইক্রোওয়েভ ইউনিভার্সে কিছু মাইক্রোওয়েভ প্রডিউস করার কথা, nothing that produces microwave, but we know that a lot of things will produce infrared, and ওই ইউনিভার্স অরিজিনালি যখন অনেক ছোট সাইজ ছিল was producing infrared. So আমার কোয়েশ্চনটা হচ্ছে, যদি ইনফ্রারেড প্রডিউস করে থাকে, ইনফ্রারেড তো দেখছি না, কি দেখি আমরা? Microwave. How can that happen? That's because the universe was expanding, the infrared is moving away from us, so the infrared underwent a redshift, and যখন infrared redshift হয়, what does it turn itself into? That's why we are seeing microwave. The microwave is actually
it produced infrared.
Infrared, right? And infrared is produced by a very small universe.